So, have you ever written a piece of C# code, smashed that run button, and just kind of hoped for the best? Well, today we're going to pull back that curtain. We're going to follow your code on its entire journey, from the moment you type it to the moment it actually does something on your computer.
I mean, think about it. It's a button we click maybe 100 times a day without a second thought. But what is that simple click actually kicking off? That's exactly what we're going to break down step by step right now.
All right, to make this whole thing make sense, we're going to use an analogy that I think you'll like. For the next few minutes, you're not a developer. You're a world-class chef. And your code? That's not a program. It's a very specific, very detailed recipe in a super high-tech kitchen. Okay, so here's the first big problem we have to solve. We're writing our instructions in C#, right? It's a language made for us humans to easily read and write. But the computer's processor, the thing that actually does all the work, it only speaks one language, the raw ones and zeros of machine code. We have a serious language barrier. So, in our kitchen, you are the chef. You're the creative genius. And your C# source code, well, that's your prize-winning recipe. Every single line is a precise instruction for creating something amazing. And when I say precise, I mean really precise. Take a look at this super simple Hello World example. Every capital letter, every curly brace, every semicolon, it all has to be perfect. Because when you're giving instructions to a computer, there's just no room for ambiguity. Okay, so we've written our perfect recipe in C#, but our main piece of kitchen equipment, the computer, can't read it. It doesn't speak our language. So what do we need? We need a translator. And that brings us to the first really critical step, the compiler. And that translator is the C# compiler. Its entire job is to take the beautiful recipe you wrote in C# and convert it into a set of instructions that the machine can start to work with. It's our kitchen's master translator, fluent in both chef speak and kitchen speak. The goal here is pretty straightforward, but absolutely crucial. As Microsoft's Bob Tabor puts it, compilation takes our human-readable code and turns it into a format that the machine can read. It's that essential first translation that gets everything started. But, and this is a really important point, the compiler doesn't translate your C# directly into the final machine code for your specific computer. Nope. Instead, it creates this universal, halfway language called intermediate language, or IL. Think of IL as a generic recipe format that any kitchen in the world can understand, no matter what brand of oven or mixer they have. Okay, so our recipe has now been translated into this universal IL format. But where does it go? What does this translated file actually look like on our hard drive? Well, every time you compile your code, this newly translated file gets put into a special folder right there in your project directory. It's called the bin folder, which is short for binary. This is the new home for the machine-readable version of your code. And that file itself is called an assembly. This is our finished recipe book. It's the .exe file you double-click to run, or maybe it's a .dll file that you share with other projects. It contains all those translated IL instructions, all bound up and ready for the kitchen. So we have our recipe book, which is awesome. But the instructions inside are still in that universal IL format, not the final, nitty-gritty machine code. To actually bring this recipe to life, we need one more player, and this one is the most important of all, the Kitchen Manager, otherwise known as the .NET Runtime. The .NET Runtime, also called the Common Language Runtime, or CLR, is like a protective bubble that completely surrounds your application when it runs. It's a super sophisticated environment that takes care of all the messy, low-level details so that you, the chef, don't have to worry about them. Now, this Kitchen Manager is a real multitasker. First, it does the final translation from that universal IL into the specific machine code for the computer it's running on, right at the moment it's needed. We call that just-in-time, or JIT, compilation. Second, it manages all the memory, creating little buckets to hold all your data. Third, and this is a huge one for us developers, it automatically cleans up those memory buckets when you're done with them. That's called garbage collection, and it saves us so much work. And finally, it acts like a bouncer, providing a security layer to make sure your app behaves itself on the user's machine. So there you have it. We've met all the players. We have the chef, the recipe, the master translator, and our amazing kitchen manager. Now, let's put it all together and watch the whole thing happen from start to finish. Here's the whole journey in 4 simple steps. Step 1, you, the chef, write your C# recipe. Step 2, the C# compiler translates that recipe into a universal assembly file. Step 3, you go to run that file. And the .NET Runtime's JIT compiler does the final, on-the-spot translation into native machine code. And finally, step 4, the CPU executes that machine code, and boom, Hello World appears on your screen. And that right there, that two-step process, is the absolute genius of the .NET framework. Compiling to a universal language first, and then letting a local runtime handle the final mile translation, that's the key. It means you can take that exact same assembly, that same recipe book, and run it on Windows, on a Mac, or on Linux. As long as that machine has the right Kitchen Manager, the .NET Runtime, installed, your code just works. It's brilliant. So that's it. That's the secret journey your code takes every single time you click that Run button. Understanding the how behind it all gives you a totally new level of appreciation for the tools we use every day. So now that you know what's really happening under the hood, the only real question left is, what are you going to build next?